Masonry Design. We want to perform a wall calculation and select the wall module. The construction type is load-bearing wall plate action and the wall type solid wall. Under geometry, we define the wall's length to 8000 mm, the height to 4000 and the thickness to 240 mm. Under support case, we choose a four-sided support type 12, meaning a fixed edge at the left side. Under material general, we select ultimate limit state and performance class 1. Under brick block, we choose lightweight concrete blocks, strength class 4, mortar class 1 and designed mortar. Under support eccentricity, we select type B1 end support at part of wall and the distance A will be 100 mm, resulting in a total eccentricity at the wall top of 86.7 mm. Finally, we define loads. A vertical load 10 kN per meter and a horizontal suction load of minus 1.1 kN per square meter. We now perform a capacity calculation and choose result. In this case, the horizontal load is dominant and the design will be according to EC6 shaft 6.3 to 6.4. Buckling will thus not be decisive, but instead the wall's horizontal capacity. In this case, the result horizontal capacity at limited axial force is active and the wall is unreinforced. The result shows that the vertical force is significantly lower than the limit for a demand of buckling check, which means that the wall's horizontal capacity is decisive. The current moment is calculated according to yield line type 3 and is significantly larger than the wall's moment capacity. We have to strengthen the wall and will try with horizontal reinforcement. We select material reinforcement and the default option for horizontal reinforcement is a bi-steel reinforcement called bi-30R Dista. A number of standard reinforcement types are available as well as ordinary reinforcement bars. We select in this case a standard reinforcement by 37R. We move on to reinforcement details, where we activate the option Use Horizontal Reinforcement if needed and select Centric Reinforcement, meaning one bi-steel in each joint. A new calculation shows that with horizontal reinforcement the moment capacity will be adequate, but one bi-steel in each joint will be required. This corresponds to an area of 78.3 square millimeter per meter, while required reinforcement is only 34 square millimeter per meter. Decisive in this case is however minimum reinforcement according to EC6 with a demand of 72 square millimeter per meter, meaning one bi-steel in each joint. This result is also displayed graphically.